Welcome to the DIY Honda Garage channel. The DTC P16F3 indicates a low voltage issue in the starter cut relay 1 control circuit of the Honda Civic models from 2016 to 2021. This pertains to a problem with the circuit that controls the starter cut relay, which prevents the engine from starting under certain conditions. The starter cut relay itself is integral to the fuel injection and ignition systems, ensuring that the engine is only started when the necessary conditions are met. Located in the relay circuit board, the relay operates by closing and opening a circuit that allows electrical current to flow to the starter motor. Thus, diagnosing this error effectively involves examining the entire range of components involved in the starting system, from the relay to the PCM, Powertrain Control Module. If you encounter this DTC, it indicates a deeper issue that requires systematic troubleshooting of the starting system components. The error represented by DTC P16F3 is related to a malfunction in the starter cut relay 1 control circuit, which is experiencing low voltage conditions. This issue directly affects the ability of the starter cut relay to function properly. The starter cut relay is responsible for inhibiting fuel and ignition signals to prevent the engine from starting under certain unsafe conditions. This relay is located on the relay circuit board, which is situated within the vehicle's under-dash area, emphasizing its accessibility during diagnostics. It plays a crucial role in ensuring that the engine starts only when it is deemed safe to do so. Therefore, pinpointing the cause of the low voltage is critical for proper engine operation and reliability. The primary possible causes of DTC P16F3 include a shorted wire in the ST cut RLY1CL line, which connects the relay circuit board and the PCM. A short may create a continuous state where the relay cannot operate correctly. Additionally, there may be an open circuit in the same wire that would prevent any signal from being transmitted. Another likely cause could be a faulty PCM, the electronic unit responsible for controlling various aspects of the engine, including starting. A malfunction in the PCM could lead to incorrect communication errors affecting the starter system. Each potential cause must be thoroughly investigated, as it significantly impacts the vehicle's ability to start. Common symptoms associated with DTC P16F3 include the engine failing to start entirely, as the low voltage in the relay control circuit directly prevents the starter from engaging. Drivers may also notice the illumination of the DTC P16F3 on the dashboard, indicating a malfunction that requires attention. Furthermore, there may be intermittent starting issues where the vehicle starts under some conditions, but fails to do so under others. This inconsistency is often indicative of underlying electrical issues that require a methodical troubleshooting approach. Recognizing these symptoms early is essential in preventing further complications. The first troubleshooting step for DTC P16F3 involves attempting to start the engine. This initial action serves as a straightforward verification step to determine the current state of the vehicle's starting system. If the engine successfully starts, this may indicate that the issue is intermittent or only occurs under certain conditions. In such a case, the process continues to the next troubleshooting phase to further investigate the scenario. However, if the engine fails to start, it becomes vital to proceed to a deeper examination of the system, specifically focusing on potential electrical failures that impact the relay circuit and its controls. This step is foundational in diagnosing the problem accurately. In the second troubleshooting step, you will turn the vehicle to the off or lock position. ensuring that the electrical systems are completely inactive. Subsequently, utilize the HDS, or Honda Diagnostics system, to clear the DTC from the vehicle's memory. Clearing the DTC is crucial because it resets the stored error codes, allowing for fresh data to be collected. After clearing, check for any pending or confirmed DTCs again using the HDS. This process helps to identify if the P16F3 code reappears, indicating a persistent fault. Should the DTC be absent, it suggests that the system may perform correctly at that moment. However, intermittent faults may still require a thorough inspection of connections and circuits. The third troubleshooting step focuses on identifying any shorted wires in the STCUT RLY1CL line. Start by turning the vehicle to the off/lock mode. Using the HDS, jump the SCS line and wait for more than 1 minute. This process helps to stabilize the system for accurate testing. Disconnect the necessary connectors, including the 50-pin PCM connector and the 8-pin relay circuit board connector. It's essential to test for continuity between specific test points. Test point 1 is located at the PCM connector A, 50P, number 15, and the second test point is the body ground. Continuity testing allows you to confirm whether there is a short present in the wire line. Establishing continuity, or a lack thereof, aids in determining the integrity of the starter cut relay circuit. Key in diagnosing and executing necessary repairs. In the fourth step, the focus shifts to determining the potential failure area, which is critical in diagnosing DTC P16F3 accurately. First, ensure the vehicle is in the off/lock mode. Proceed by jumping the SCS line with the HDS and waiting over a minute. Disconnect the PCM connector A, 50P, before moving to check the voltage between the designated test points. In on mode, measure the voltage at test point 1, the 50P connector number 15, and test point 2, the body ground. If battery voltage is present, this directs the technician to consult authorized service information for further instructions. The verification of voltage helps ascertain whether the components are functioning as expected, offering insight into whether the issue is isolated to the relay circuit or encompasses a broader range of parts. The fifth troubleshooting step involves checking for an open circuit specifically in the ST-CUT RLY1CL line. Begin by turning the vehicle to the off/lock position. Disconnect the relay circuit board connector A, 8P, to facilitate accurate testing. The next phase is to check continuity between test points in an off condition. Test point 1 is at relay circuit board connector A, 8P, number 5, while test point 2 is at PCM connector A, 50P, number 15. By verifying continuity, you can ascertain whether the ST-CUT RLY1CL wiring is intact. Should continuity be present, it indicates that the line is functioning correctly, allowing you to proceed to subsequent steps. However, if continuity is absent, it signals an open circuit that requires repair, ensuring all wiring is securely connected and free of damage to restore the circuit's integrity. Step 6 requires checking the integrity of fuse number B2110A, located in the under-dash fuse and relay box. Fuses are essential in protecting electrical systems from overloads, and a blown fuse may suggest a short circuit condition elsewhere in the wiring. Once the fuse is inspected, determine whether it is functional. If the fuse is intact, the process moves to the next step. If it's blown, this necessitates checking for shorts within the IG1 ACG wire running between the B21 fuse and the relay circuit board. Shorts can cause unexpected behavior and must be rectified before replacing the fuse. This ensures that the circuitry does not experience further damage from a recurring overload situation. Checking fuses thoroughly is crucial in troubleshooting such electrical issues effectively. The final troubleshooting step involves checking for an open circuit in the IG1 ACG line. Start by disconnecting the necessary connectors, including the under-fuse relay box connector and relay circuit board connector B. After ensuring that everything is disconnected, connect terminals A and B using a jumper wire. Terminal A corresponds to the under-fuse relay box connector C27P number 6, which you will ground. The next phase is to check continuity between test points 1 and 2. These are located at relay circuit board connector B, 6P, number 4, and body ground respectively. Determining continuity at this point will reveal the status of the IG1 ACG wire. If continuity is found, the wiring is functioning, signaling a need to replace the under-fuse relay box. If continuity is absent, it indicates an open wire that requires repair to ensure an uninterrupted electrical flow in the starter cut relay control circuit. After completing all troubleshooting and repairs associated with DTC P16F3, it's vital to conduct a final repair verification. This process involves confirming that all identified issues have been effectively addressed. Begin by ensuring that all connectors have been reattached properly and any wires that were damaged have been repaired or replaced. Once the repairs are confirmed, the next step is to clear the DTC from the vehicle's memory using the HDS or another diagnostic tool. After clearing the DTC, it's essential to retest the system by attempting to start the engine multiple times to ensure that the issue no longer persists. A successful start without the reappearance of DTC P16F3 indicates that the troubleshooting and repairs were successful, restoring the starting system's functionality to optimal levels. Preventive maintenance is a crucial aspect of ensuring that the starter cut relay system remains operational and minimizes the potential recurrence of issues like DTC P16F3. One effective approach is to regularly check all electrical connections for signs of corrosion, wear, or looseness. Ensuring that every connection is secure and clean can help prevent intermittent failures. Regular inspections of fuses, particularly those associated with the starting system, should also be a key part of maintenance. A proactive approach allows for the timely identification of blown fuses or weak connections before they lead to significant starting problems. Implementing these best practices enhances vehicle reliability and ensures optimal performance. In conclusion, diagnosing and addressing DTC P16F3 requires a structured approach to accurately identify the faults within the starter cut relay control circuit. Systematically following the outlined troubleshooting steps ensures that no aspects are overlooked, from checking for low voltage conditions to examining wire integrity. Understanding the functions and locations of components involved, such as the starter cut relay and the PCM, is essential for effective diagnostics. Addressing any wiring issues, whether they are shorts or opens, is vital in restoring the system's functionality. By implementing proper preventive maintenance, you can help avoid the recurrence of such problems, ensuring that your Honda Civic's starting system remains reliable and effective over time. This thorough approach to diagnosing and repairing DTC P16F3 can lead to improved vehicle performance and longevity. Please like and subscribe to the channel. See you next time!